So we're finishing up our last unit of geometry now, and this is where everything starts to come together. So we're going to use all the theorems and postulates and definitions that we've been studying all year and combine it all together now for our final bit. But first, let's take a back step and go back and see exactly what's going on with some algebra ideas. So printing out your notes, let's take a look at our notes for this section 16.1. And here we go. So we've already discussed flowchart proofs earlier this year. We did triangle proofs where we proved congruent triangles. We did similar triangle proofs. We've done a lot of these types of things. And in all of these, they're all based on four basic arguments. The four things we use to defend our statements in proofs. The first is definitions. Okay? Knowing things like what a midpoint is, knowing things like what a rectangle is, all that type of things. Then we have algebraic properties. And that's really the focus of this particular video. Some properties that you learned in algebra that you may not have actually really focused on, but are going to be useful now. Then there's geometric postulates. Geometric postulates are things that we learned in geometry that just are what they are. Okay? They're the things that we're used to seeing. And a lot of that comes from back when we were first studying geometry. A gentleman by the name of Euclid, way back in the old days. He was the one that sort of came up with the 5 basic postulates of geometry. The 5 things that all geometry is based on. 2 lines make a point. A circle is all the points equidistant from a line. He came up with the idea that 2 parallel lines never intersect. And from all these first 5 postulates, he began to prove other things. And then other mathematicians took that book and began to prove things. So if you're interested in studying on some of that, you can easily go in and study some of the stuff that a guy by the name of Euclid did. So it's, in fact, all of the geometry we've been studying is known as Euclidean geometry, based on his postulates. But once we got to that, then we started to prove other things. From definitions, properties, and postulates, we began to prove other theorems. So previously proven theorems. And that's anything that we've already proved to be true. We can use that to prove new things. Then we can use those new things to prove other new things. So this is what we're really focused on in this unit, is using this type of stuff to do our proofs. But like I said, we're going to start right here at algebraic properties. So let's look at some basic algebraic properties that you know. Okay? The reflexive property. This is one from ages ago. Reflexive property says a quantity is equal to itself. Okay, so if we're talking about basic, say, I don't know, anything like a number, the number 3 is equal to the number 3. That's reflexive property. X equals X. That's a reflexive property. We used this earlier in the year to say things like angle ABC is congruent to angle ABC, because they're the exact same thing. So it's equal to itself. Then we've got the transitive property. Now, used to be these were 2 separate properties, but more and more people are starting to realize they're really kind of the same thing. So I'm good if you use transitive or substitution. I tend to use substitution more often. But basically it says if A equals B and B equals C, then A equals C. So it's substitution because in place of this B, I'm putting what B equals. So I'm putting this A in place of B to get A equals C. It's transitive because it says if I can go from here to here and then take that same thing, I can go to the next stop. So that's why both of these things kind of work the same way. You've used this in algebra. You've had problems where you may have had an expression, x plus 5 equals y, and maybe you know x equals 7, so therefore 7 plus 5 equals y, something like that. In geometry, we can use it to replace different types of things. I could say angle C equals 90 degrees. Angle A plus angle C equals 180 degrees. Therefore, angle A plus 90 equals 180 degrees. I replace C with what C equals. And we can do it with numbers. I can do it with other things. I can do it basically with anything. As long as I know two things are equal and another set of stuff is equal, I can replace one of the things. Okay? Symmetric property, we don't use symmetric property too often. But it basically says if x equals y, then y equals x. Okay? It's what allows us to switch our answers. Back when you were in algebra, sometimes you got an answer that was like, oh, 50 equals x. And then your teacher might write, oh, but x equals 50. Those statements say the same thing. Okay? And it's a symmetric property that allows me to do that. So once we got those three basic ideas of something equals itself, I can replace things, or I can flip an equation around. Once I know that, then I start actually doing some work. And we have the properties of addition, subtraction, multiplication, and division. All four of these say the same idea. They're just using different arithmetic. Here's the catch. This addition is not the same as 7 plus 5 equals 12. Okay? That's the act of adding. This addition property is what allows you to do algebra. It says if A equals B and C equals D, then A plus C equals B plus D. Basically, it says you can add the same thing or equal things to both sides. So in algebra, you may have had x minus 5 equals 10. Then you could say x minus 5 plus 5 equals 10 plus 5. Okay? Even if I had x equals 7, y equals 8, then I could say x plus y equals 7 plus 8. Okay, so that's the addition property. Notice I'm not actually combining things. Combining things is simplifying. Okay? We're not simplifying. We're actually just saying I can add the same thing to both sides of the equation. Or I can add equal things to both sides of the equation. And if I can do that with addition, I can do that with all of these. If A equals B and C equals D, then A minus C equals B minus D. So that's subtraction property. Multiplication. If A equals B and C equals D, then A times C equals B times D. And then division. If A equals B and C equals D, then A over C equals B over D. There is a slight catch though, as long as C does not equal 0 and D does not equal 0. If one of these things were to happen, if C equals 0 in this problem, then the whole division doesn't work. But that doesn't often happen. In fact, I don't even care if you remember this part or not. The minute you're dividing by 0, you know you've got a problem. So these are our basic properties, and we'll use these quite a bit. In fact, these four get used a lot. Reflexive property gets used a lot. Substitution gets used an awful lot. Okay? So let's look at how these can be used to do basic algebra. Okay? First problem. We've seen these flowchart proofs. So the part of it that is the given is this statement, the if part. That's my given information. The then part is what I'm trying to prove. Okay? So that's the part that I want to prove. So when you see these if-then statements, that's what it's talking about. So now I've gotten that, I've got a flowchart proof set up. So looking at this flowchart proof, what do you think is the reason that I can say this first statement? Go. Hopefully you realize that the reason I could say this is because it's what given to me. So this is just given. And then we go to our next statement. How did I get from here to here? What did I do algebraically? See if you can remember that. Hopefully you realized that all I did was distribute. So that's distributive property. Okay? That's old stuff. That's stuff from algebra. So still working with algebra now. Taking in this step. Look at what we did here and how it's simplified. So what I did here, I added 12 to both sides. So that's addition. Now, some students don't like to write that step out because you're so smart you can just do the addition and know what it comes out to. But this is a proof. You have to have this written in there. Okay? Don't write the 12 underneath it because that's algebra scratch work. This is a mathematical sentence that says that I added 12 to both sides and then I simplified it to be this. Okay, so yes, you have to write it out like this. Next part of it. What happens in the next statement? What's my reason for it? Hopefully you realize you subtracted 3x on both sides, so that's subtraction. Subtracting on both sides is subtraction, and then I just simplified it. And the last statement. Okay, you saw that was division. I just divided both sides by 2. That got me to my x equals 9. So now I've proven that x equals 9. Rather than in algebra last year where you had to solve for it, we already know what it should equal. We've gone through and proven it. Okay? So let's try another one. This one, however, is more abstract. We always start proofs the same way. I'm going to start with my given information. ax plus b equals c. That is my given. So what happens next? Take a moment to go, what am I going to do? What property might I use next? Hopefully you realize that you want to subtract b on both sides. ax plus b minus b equals c minus b, which can reduce to ax equals c minus b. And that is subtraction. What would be my next property that I can use? So hopefully you realized that I want to get the x by itself, so I need to divide by a. When I simplify that, we get this statement, so I can take that, and that is using my division property. So these algebraic proofs are very, very simple. Okay? All right, let's try some more. So try this one on your own. Give it a good start. Go through step by step. When you get done, tune back in. So now that we're done, hopefully you're able to complete your last step. Now your last step could be a little different than mine, but let's see what happens. So 5x minus 12 over 4 equals 3, 2x minus 7. That was my given statement. Now I'm dividing by 4, so to undo that, I'm going to multiply by 4 on both sides. Actually, no, I'm sorry. I missed my distributive property. So let's do that first. 5x minus 60 over 4 equals 6x minus 21. Distributive property. Okay, I try my next step. Now I'm going to multiply by 4 on both sides. So 5x minus 60 over 4. And yes, you do have to show the work here. You can't just do it in your head. Otherwise, you're not proving it, you're just saying it's true. And then I simplify it. So I show the multiplication on both sides and then simplify. This is actually multiplication. Multiply 4 on both sides. I'm going to take that, and now I'm going to add 60 to both sides. You may have added something else. You may have gone about a different route for this, but this is how I'm going to do it. There's more than one way to solve these. You just have to make sure that you're doing it logically and backing up everything you do. So let's see. I added 60, so that's addition. Let's go in this direction now. Now I'm going to subtract 24x on both sides. So that's 5x minus 24x equals 24x minus 24 minus 24x, which reduces to negative 19x equals negative 24. And again, that was subtraction. The last thing I need to do now, divide by 19 on both sides. Now, do take note here. If you did it in a different way and you had these switched around, so you had 24 over 19 equals x, you need one more step. You've got to use the symmetric property to get it to look like this, okay? Because it actually, your final statement should look exactly like it says here. Okay, this I used division, and I made a conscious choice to keep my x on the left-hand side. But if you switched it and your x is on the right-hand side, you need to use the symmetric property to flip that around. That was pretty easy. All right, let's do one more together, and then I'm probably going to let you try some on your own. We'll work this one. Now you're going to give a reason for each step along the way. Okay, so first of all, a plus b equals 180. You know what? We know that's given. We know c plus d equals 180. That's given. I also know a equals c. So all of this is given to me. Okay. Well, I look at these two and I see they're both equal to 180. So in algebra, I'd say, oh, set them equal to each other. But set them equal to each other is not a mathematical property. So take a wild guess, looking at our mathematical properties, and tell me, what did we do to get to this statement? So what I did is I took, in place of this 180, I put what 180 was equal to. In other words, I substituted c plus d in place of that. So that's substitution. Excellent. Now I've got a equals c and this thing here. And I'm trying to get b equals d. So I think about it for a little bit. And I go, well, since a equals c and I have this equation here, I'm going to take this side of the statement, a plus b, and subtract a. I'm going to take this side of the statement, c plus d, and subtract c. What is my reasoning for that? Hopefully you said subtraction. Of course, what I didn't do is leave myself enough room here. I should have left a little bit of room so I could actually then say b equals d. So that finishes off my proof. Okay? Always, whenever you do the subtraction, you're probably going to have to leave a little bit of room to simplify it. And that's my final answer. Make sure you have that, which is equal to that thing there. So that proof is done. All right. Good job. Next thing we need to do, let's do some matching. So match each of these statements up with this. And after you're done with that, you're going to try some proof answers. Okay? These will be posted online, and that's all we've got going on. Tomorrow we'll come in, we'll see how this matches up with geometry type problems. So again, match this up, and then do your proofs and check your answers. Have a good night.